Today we're going to be graphing simple rational functions, and we'll be able to use our calculator for this, and we'll talk about domain and range again. So first off, get your calculator out. I'll show you what we call a parent function of a y equals 1 over x looks like. So take out your calculator, make sure you hit zoom 6. Also make sure that you punch in your y equals, and let's get a picture of what our simple rational function looks like. So again, if you just punch in 1 over x, graph it, and the calculator kind of looks a little weird. Let me show you how we're going to get to some points. We're going to end up with an error again. And what does an error mean? If I stick in 0, I can't divide by 0. So we're going to end up with what we call a vertical asymptote. Vertical asymptote. This is a line that the curve gets closer and closer to, but never ever touches. And if I graph the point -1, -1, if I graph the point 1, 1, and these curves are going to look a little weird. We've seen these before. These are called hyperbolas, and hyperbolas have what we call two branches. This is a branch, and so is this. A hyperbola has two branches. And to get those values, you'll go into the second table and get those values, plot those points. We also have what's called a horizontal asymptote. Horizontal goes side to side. And a vertical asymptote is a line that the curve gets closer and closer to, up and down. Okay, so these will basically have the same shape. Let me review what we talked about already. Make sure that you've got your notes down. As far as a vertical asymptote is a line that the curve gets closer and closer going up and down. A horizontal asymptote is a line where the curve gets closer and closer to going sideways. So if we look at the next example is a y equals 6x, 6 over x. So again, if we take out our calculator, we're going to have kind of the same type of shape, but now our curve is going to be a little bit more pronounced. If we have 6 divided by x, we graph that. We're going to have two branches. We'll have a branch that will be, let's see if I can get this over here so you can see how we get these values. So we're going to have what's called a horizontal asymptote, where the curve gets closer and closer to. I want you to graph that with a dashed line. And you can see the vertical asymptote is the one up and down. This is right at the y-axis. And then how do you get the shape of these curves? The best way to get the shape of these curves is our branch kind of comes into that asymptote and close to the vertical asymptote, and draw your two branches of your hyperbola. Okay. To get some exact points, we'll do like we usually do, which is what? To hit second graph. How many points should you use? You should do a couple of these exact points and connect them. Again, why do we have an error? Because we can't stick in x equal to 0. The domain is how far right and left we go. So we go forever and ever right and left, except for x cannot equal 0. That's how we'll write that. Our graph goes down for forever and up for forever. So again, that kind of looks like an all reals, but y, no matter what we plug in, will equal, y cannot equal 0. Okay. So make a note, these will be your vertical asymptotes, and these will be your horizontal asymptotes. The graphs will look similar with when we choose a negative 4 over x. So if we look at, we'll still kind of have a hyperbola. And again, we can't divide by 0. So domain will be everything except for 0 again. And if you made note, this will be your vertical asymptote. So go to your vertical asymptote. We'll learn in a little bit that if there's a number in the top only, our y will never equal 0, and that's our horizontal asymptote. Okay. So again, make yourself a note. That will tell you how high you go. No matter what, y won't equal 0. When I graph this, it will look like a hyperbola. But now this time, it will be instead of the first and the fourth quadrant, it will be in the second and the fourth quadrant. Instead of being in these two quadrants, now you can see that your branches are in what we call the second quadrant and the fourth quadrant. How do you get those exact points? Again, hit second graph. You see some points. 0 is a error, so that's your asymptote. You have negative 1, 4. That's how you'll get your shape there. Negative or 1, negative 4, excuse me, is down here. Negative 1, 4 is up here. Negative 2, 2. So that's how we get our shape. The point 2, negative 2, 2, negative 2 is here. That's how we'll get our 2 branches. Now, as we add to our graphs, we're going to see a couple different things. These are the rules. When you graph some things in, we'll have asymptotes. And remember, asymptotes will have a couple different asymptotes. The x equals asymptote is your vertical asymptote. Your y equals are your horizontal asymptotes. So what we will see in this example, let's look at our h. Our h here, if this is a +2, our asymptote is x cannot equal -2. And where does that come from? If x equals a -2, +2 would be 0, and we can't divide by 0. Okay. The horizontal asymptote is y cannot equal, let's look at our pattern. Whatever this number is on the outside is what y cannot equal. Okay, so y cannot equal a -1. So before we even graph this on the graphing calculator, let's use what our asymptotes are. So y cannot equal -1 means that y cannot equal -1. X cannot equal a -2. So we're going to have these asymptotes where the curve gets closer and closer to. And when we state the domain, we'll say all real but. And then when we graph this, we'll just have to be real careful when we graph that we put our parentheses in the right spot, and we'll get our 2 branches. Okay, so if you can make sure that you put down your domain, your range, go ahead and sketch in your asymptotes with dashed lines, and then I'll show you when we punch it in the calculator how we'll get the shape. So when we put in the y equals, be careful that we have y divided by, and in this case, the whole bottom is x + 2, so you have to put that inside of parentheses. And then you're going to add on the -1 after the fact. Okay, so this will give us that hyperbola that we have already graphed in our asymptotes. And we can see our curve gets closer and closer to -2 down, or -1, but never touches. And our curve comes up here close to that -1 as well. So that's how we'll sketch those in. If you want exact points, hit second graph and get exact points. So looking at example 4, again, you'll want to get an idea of where your asymptotes are going to be first. So look up at your model. We have our domains are all reals, but x can't equal 1, and again, why 1? Because if I stick in 1 minus 1 is 0, and I can't divide by 0. And this number that's out here is what y will never equal. So here we'll have a y can equal 2. Here we'll have a x cannot equal 1. And then when we punch it in, we'll expect a hyperbola. We might be surprised that our hyperbola is going to take a little bit different shape, but we'll see what happens when we have a -3 in there. Okay, so first draw your asymptotes, state your domain and range, and then get some points. How do I do that? I have to graph it in the graphing calculator. Okay, so let's change this up. We put in a -3. Again, since x minus 1 is in the bottom, we have to put that under parentheses, and then we put our +2 outside of parentheses. So in this case, my vertical asymptote was actually graphed. I don't know if you guys will see that vertical asymptote graphed, but we put that vertical asymptote in there. We put that horizontal asymptote at 2, and we can see our curve kind of comes into that 2 on the upside and down to 2 on the other side. So I'd like you to try some problems, and then we'll go back and work with the most difficult problem, number 5, together in class.